Hello class, so today we went over Beer's Law, and I'm going to expand upon that now just because we didn't have quite enough time to go over that in class in depth that we needed to. So Beer's Law we know looks like this equation here. We have our absorbance equal to the epsilon length value and our concentration. And we said in class today that this can be likened to the y equals m x, and then plus b is just 0 here in this case. So our epsilon and length of the cuvette is equivalent to this slope value, and that's what we were looking for in our sample dilutions today from the stock. So the main goal that we're interested in was finding grams of our unknown dye. So we needed to know the grams in our unknown dye. That is our main goal here. So everything we do subsequently from now is for this goal, to find the grams of our unknown dyes. So by using this Beer's Law, we can rearrange it as we did in class, and that was the concentration equaling to absorbance over epsilon times length. Each of these has certain units that we're expected to know. Concentration we know is molarity, which is moles per liter. We know that the epsilon value here, if you look back at the PowerPoints, is the moles per centimeter, which also looks like moles per liter times centimeter, because this molarity is the same thing here, the moles per liter. And our length was measured in centimeters. So you should be able to see here that the centimeters and the centimeters cancel out. What we're left with is this moles per liter, which is what we would expect for our concentration. So moving on, how do we use this to solve for the grams of the unknown dye? Well, that's the question of the day, isn't it? So the first thing we want to think is, well, why did we get the absorbance of our unknowns? We found that absorbance through the lambda max. So at the certain wavelength in nanometers, there was an absorbance. So at a certain wavelength, there was a maximum, as we had in our graphs. So at this wavelength, we had an absorbance here. That absorbance will get plugged in there. Our epsilon value here is why we did our dilutions with the stock sample. So this value that you gained from your slope in the calibration plot is what you need to plug in here. If you plug in your absorbance of your unknown from the lambda max and your epsilon value that you calculated from your calibration plot, and that was from the stock solution, times the length of the cuvette, which was 1 centimeter, as you all remember, you'll then have a value. And that value will be in moles per liter for concentration. Great, so now what? Well, our goal, if you remember, is to get grams of the unknown dye. Right now we're stuck with moles per liter. So we need to somehow get rid of this liter if we can, because then we'll be stuck with moles, and moles can be easily converted to grams. And then we'll accomplish our goal. So if we can get the concentration that we just found and knock out the liters, or the volume, then we can find the moles. So how do we do that? Well, okay, let's say we're trying to find moles. So let's say moles of our unknown is equal to this concentration value that we have here. I'm going to call this C. That's our concentration that we've already solved for, and that's in moles per liter. And then if we multiply it by some volume, which you guys should know which volume I'm talking about, that would be in liters, or L over 1. I put L over 1 so you can clearly see that the liters cancel, and now we're left with moles. So now when we multiply these two numbers together, we should have a value that's only the moles of our unknown dye. All right, great. Now how do we go from moles to grams, right? Again, fulfilling our goal. Well, if we want to know grams, the easiest way to do that would be to use the molar mass, and that would be in grams per mole. That should have been on the stock bottle. So if you looked at the stock bottle and wrote down that information, you could solve the mass of your unknown dye in grams, would be equivalent to taking this mole value that we just solved for, and then multiplying that by the correct stock, so the molar mass of the correct stock, and that's in grams per mole, whatever that value is for the stock. And now you can see these moles cancel, and we're left with grams. And that is how you would find the grams of your unknown dye.